Okay, here we go. Use the cosine rule to show that cos A plus cos C is 7 over A. Okay, so what we said yesterday was we're going to go for the standard cosine rule, this one here. And we're going to target cos A straight away. And when we target cos A, we're going to find it's, what's A squared going to be? 4 squared equals 5 squared plus 6 squared minus 2 times 5 times 6 cos A. It's going to be minus 60 cos A. That's going to be 16, and that's going to be 61. Put the 61 to the other side. Minus 45 equals minus 60 cos A. And then what we're all going to find out is that minus 45 over 60 is what? Huh? Yeah. 3 over 4. Are you cool with that? Now, we have to do the exact same method for what? Cos C. So we're going to do the exact same method for cos C. So here we go. Now, cos C. C squared equals what? We're doing an interchange. I replace any A's with C. So C squared equals B squared plus A squared minus 2. What's it? 2AC? Sorry. So 2BA cos C. Okay. So what's C in this question? Opposite big C is small c. And what we're using 4 and 5 then, yeah? Okay. Now, that's going to be 36, take away 16 and 25, which is 41. 36 take 41, minus 5. And then that'll be minus 40. And we're going to find out that cos C is 1 over A when we're done. Now, we're going to prove what I asked us to do here, up here. It's 3/4 plus 1/8. What's 3/4 plus 1/8? 7/8. So we've successfully proven what cos A and plus cos C is. We all right with that? Next part. Show that cos A plus cos C is minus 9 over 16. Cos A, prove it's minus 9 over 16. Here's what I'm going to do. What rule am I looking to use? From page 14 of your tables. I'm going to use cos A plus B. And what is cos A plus B? Sine A, sine B. Now, I haven't got a B. What do I haven't said? Anywhere I see the B's, I'm going to put A. Is that all right? Another issue. I know what cos A and I know what cos C are. Okay? I know that cos A is 1/8, is 3/4, and I know that cos C is 1/8. What's my problem though? I don't know what. I don't know what sine A and sine C are, so that's an issue. So we got to fix that. So here's what I'm thinking. Okay, let's draw a right angle triangle for A. Who's the hypotenuse? Which one? The 3 or the 4? It's the 4. The adjacent is 3. Do Pythagoras' theorem. You're going to get 16 take away 9. 16 take away 9? 7, which means the other side is root 7. And then on the other one, for C, we have 8 as the hypotenuse and 1 as the adjacent. 64 take away 1. 63, so the other answer has to be root 63. Now here's what we're going to do. What do we replace cos A with? Cos A gets replaced with 3/4. What does cos C get replaced with? 1/8. What does sine A get replaced with? Sine A? Root 7 over what? Over 4. What does sine C get replaced with? Root 63 over 8. Will everybody throw that into the calculator for me? I'm hoping the answer is minus 9 over 16. Everybody cool with that? The answer is minus 9 over 16. Anybody get that out? Okay, they give me a diagram. And what they want from me is they want tan theta plus 45, or otherwise find two possible values of h. Okay, interesting. I'm going to start off with the small triangle. What's a small triangle? Does everybody see what I'm drawing? Theta here and what's a h and 1. Is that okay with you guys? Now, I'm also going to draw the large triangle. Okay, I'm going to draw the large triangle in a slightly different orientation. Okay, what are these two angles combined? What are they? Or theta plus 45. Why am I favoring theta plus 45? Because that's what's written down here, isn't it? So you're theta and you're 45. Okay, what's the yeah, it's 6, isn't it? Okay, do I know the adjacent? Oh, so it's h, is it? That's handy. All right, cool. Let's see what I can do with this. Ready? By using the formula tan theta plus 45. What is tan theta plus 45? What formula should I'm in the double angle formula chapter, aren't I? The whole basis of this chapter is using these formulas here. So what's tan A plus tan B? A tan B. Yeah. What would be a good first choice to do here? What should I replace A with? Replace A with theta. So tan theta, yeah. Replace B with 45, and tan 45 is 1. And then what's that? Just tan theta times 1. Is everybody happy with how I start the question? They told me to use, if you read the question, they told me to use tan theta plus 45. I'm just following their instructions. Everybody see that? Just following their instructions, nothing more, nothing less. Cool? Okay, next part. Using my large triangle, what is tan theta over 45? So what is tan theta plus 45? 6 over h, because it's opposite over adjacent. See that? So what am I going to replace? So what I can do there is I can say that all of this equals what? 6 over h. How many variables do I have in this formula? 2 things I don't know. Isn't there? What are the 2 things I don't know? I don't know tan theta and I don't know h. That's an issue. Anybody suggest a triangle I haven't used yet? Which triangle have I not used yet? I haven't used a small triangle yet. Tan theta is what? Oh, well, that's convenient. What can I do now? Anywhere I see tan theta, replace it with? Yeah, that's exactly what I'm going to do. Okay. Let's leave the 6 over h on its own for a second. Or will we? Actually, no. No. Let's not be too complicated with this. I'm going to cross multiply. Does everybody know what I'm going to do? How to do that? 6 times what? 1 minus 1 over h. On the other side, h times Okay, let's see what we can pull out here. 6 minus 6 over h is the same as, what's h times 1 over h? Okay. Common denominator. This question wants two values of h, doesn't it? That implies a quadratic equation. So how am I going to get a quadratic equation out of this? Multiply both sides by h. Bring it all over one side. H squared, that's going to be a 0 there. 1h take 6h is 5h plus 6. Solve h minus 2, h minus 3. H equals 2 and h equals 3.